Hello, so today we are going to do this problem called Fibonacci numbers. So basically what the problem says is that it's a standard Fibonacci problem. It's usually given as a problem either for recursion or dynamic programming. But here basically it's Fibonacci sequence, and we have f of 0 is equal to 0, f of 1 equal to 1, and this is the formula for Fibonacci. Right, and given an n, we want to calculate the value of fn. So pretty straightforward. We have some examples here, but I think we can just get started. So the simplest solution is just to do a recursion, right? To do a recursive solution. So that would be, I'll just have something like recursive here, n, right? Let's call it maybe a, right? And then we know that if it's 0 or 1, we need to return the exact value of the parameter, right? So if it's 0, 0, if it's 1, we need to return 1, okay? So what that would mean is that here we need to check. So what that would mean here is if a is either 0 or 1, so then we need to return the value. Otherwise, we need to just return this formula here. So let's just copy it over and just replace with our function name, okay, and return. And then here we can just call our function, let's call it recursion, okay, on n, right? This should work. However, for longer numbers, for bigger numbers basically, we'll be doing a lot of repetitive work. So for example, we'll do 3 for n minus 1, and then we'll call it again for n minus 2. And so we can just cache the result here. You can do it with a hash, or in Python you could just do LRU cache here. If you want to do the cache route, then that would be just having an array, maybe call it memoization here, of a. So one thing I forgot here, this should be a, right? So you do memo of a is equal to this, and then at the end you return the memo of a, right? And then here you'll check if, let's actually do that before LRU cache. If a is in the cache, then we just return it, okay? Otherwise we calculate, and let's try this. Yeah, we need to define our hash map first, so that would be like this. Okay, let's use more examples here. Okay, let's submit. Okay, so that passes. Now, yeah, as I said, in Python you could do it simpler. You don't need to do this repetitive work each time that you want to use a cache. So instead you could just do return right away here, remove the memo, and then just LRU cache. So like this. Okay, let's run this and submit. And this passes as well. So this is using a recursive solution with a cache. We can also use, of course, dynamic programming and just pre-compute all numbers before n, and then at the end compute n, and do each calculation just once. So it would be pretty similar to this. What we need to do is we no longer need this, right? We need a DP array, so we'll just fill it out initially with 0. But since we want to return here for n, we'll do DP of n. So that's why I did here n plus 1, so that n is of DP of n is valid. Now for a equal to 0 or a equal to 1, we need the value to be a, right? So for a equal to 0, we already have 0, so that one already works. But for DP of 1, we just need to assign it to 1. So, and that takes care of that. Now for this condition, we want to do it for all numbers from 2 to n, right? We want to fill this here. That's what we are doing with the recursion. So to do that, we'll just do for I in the range of starting from 2, because we already did 1, up until n plus 1, because we want to fill the value for n. And then here, we just say dp of I, and then just replace this. So this needs to be dp, and this is now I minus 1. And so just the same formula, and this is dp of I minus 2. Okay, and then here at the end here we just return dp of n. Now one thing we need to be careful of is this starts from 2, right? So we need to handle the case where n is equal to 0, right? And so to do that we just say return n if n is smaller or equal to 1. We want to return n. So if it's 0 we return 0, if it's 1 we return 1. Okay, and now we can just run this and submit, and this passes test cases. Yeah, so that's the main idea here. Now one thing you will notice with this dynamic programming solution is actually we only are using the two previous values for in the array to compute the next one, right? So here we are using O of n time and O of n space, right? We have to use O of n time, but can we not use the O of n space? Can we reduce this one here? Well, we can see here we are using just the two previous values, so why not just remove that? So let's call this here current. So dp of I is just the previous value, so the previous current, and so let's call this current, and let's call the value at 0 previous. So previous is going to be 0, and now we no longer need this. Now this is the new current value, and so the new current value needs to be the previous current value, whatever we assigned in the previous for loop iteration, plus prev. And what should be prev? Prev should be the previous current value, right? So this one here, okay? But the problem is if we overwrite it, then this prev won't be the previous value that we want. And so to do that, we will just use Python's yeah, so if you are using another language, you can just use a temporary variable, right, to put current, and then you can assign this here to temp. Yeah, so and this pretty much should be it, except here what we want to return is current, because that's the latest updated value here at the nth iteration, essentially. So if we run this, it should pass. Okay, let's submit. Okay, so that passes as well. Yeah, so this one uses just O of n space, so it's more efficient here. Yeah, so that's pretty much it for this problem. Thanks for watching. Please like and subscribe, and see you on the next one. Bye.